All right, I hope you can hear me well, but we're going to work on some systems of equations word problems. Hope you've had a good couple of snow days and that you have another good one tomorrow, or today, I guess whenever you watch this. If we can do this way, then we can spend a lot less time on it in class, and move on to the next thing. Sorry if this isn't perfect the way I'm going to write and record and everything. I'm doing this screencast on my phone, and it's not work as easy as my iPad. Alright, so remember that when we have solved systems so far, every single time there have been two equations. That's not going to be any different now. We're just going to have to make the equations ourselves from the word problem. So if we look at this one, we're talking about, we're talking about Kristen. We're talking about how much she spent on shirts, $131 on shirts. We know that fancy shirts cost $28 and plain shirts cost $15. We want to know if she bought a total of 7, then how many of each kind can she buy, or did she buy? The two things that we're looking at here are fancy shirts and plain shirts. And this is the number of those, not their price, but the number of how many she bought, because that's what I'm trying to figure out. So we're going to make X be the number of fancy shirts and Y be the number of plain shirts, because those are the two things we're trying to measure. We also know that she spent $131. So we're going to have a money equation and we're going to have a number of shirts equation. All right, so we know that she spent $131 on shirts. That's what it says. So we know that our money equation should be equal to 131, because that's the total money she spent. We know that fancy shirts cost $28. So 28 X would tell me how much money I spent on fancy shirts. $28 times however many fancy shirts I bought, which is X. We also know that she bought plain shirts, so we're going to set it up the same way for plain shirts. And those totaled together, so plus, are going to make her total money she spent. So $15 for each of those. And we said Y would represent plain shirts. Our problem also says if she bought a total of 7. So total number of shirts we know should equal 7. Well, what are the two kinds of shirts she bought? Fancy shirts and plain shirts. So we can just write X plus Y equals 7. The number of fancy shirts she bought plus the number of plain shirts she bought should equal 7. We don't know what X and Y are yet, but that means maybe she bought 3 fancy shirts and 4 plain shirts, or any combination that makes 7 total shirts. But we have to make it where that combination also adds up to be $131. That's why we're going to solve a system. So, remember, now it's just like solving when we have in class. We said that when neither of them are equal to Y or X, we need to make one equal. So this one would be pretty easy to rearrange. If I subtract X from both sides, I'm going to have this cancel and y equals 7 minus x. Now, I can take that and plug it into my other equation. So I'm going to start writing that one out. 28x plus 15. Now instead of y, open a parentheses and put what y equaled. And then finish it out. Equals 131. Now I'm going to solve that, which we have practiced. So, distribute. This is not working too bad. Just sloppy. So, 15 times 7. Oh no, I don't have a calculator. Let's see here. 15 times 7 is 105. Okay, so 105. And then 15 times negative x is negative 15x. Bring down the rest. Remember, that was a positive 105. Okay, combine like terms. 28x minus 15x would give us 13x plus 105 is equal to 131. Subtract 105 to cancel it out. 5, 20, 26. And then the last step over here would be to divide and get x is 2. All right, so we got half of our answer. That says that we bought 2, and remember x was fancy shirts, so we bought 2 fancy shirts because this is a word problem, so it's in context. Now we got to go back and find y. So we knew that x was 2, so we can now use our equation for y and plug in 2 where x was, right here. So 7 minus 2 is 5. So if I were going to write my answer in context of what the problem would ask me, y was plain shirts, x was fancy shirts. So I bought 2 fancy and 5 plain. That's what that problem asked you. Let's do another one. So this is going to get weird for a second because I got to get out of this one and go to the next one. Okay. All right, this one's going to sound a little weird. All right. So there are 13 animals in the barn. Some are chickens and some are pigs. There are 40 legs in all. How many of each animal are there? So we're looking for how many of each of chickens and of pigs there are. So chicken and pigs are the two things I'm going to mess with. So I need a number of chickens, and we'll make that x, and a number of pigs, and we can make that y. So we know there's 13 animals, but it also tells us something about the 40 legs. So we're going to need 2 equations again. Every system has 2 equations. So we're going to have a number of animals equation and a number of legs equation. All right, so we know that there are 13 animals in the barn. So our total number of animals should be equal to 13. We know that the only kinds of animals in our barn are chickens and pigs. Well, we said chickens were X and pigs were Y. So if we add up the chickens and the pigs, x and y, we should get 13. We also need a legs equation. So there's one equation. We need a legs equation. It says there are 40 legs in all. 40 total legs. Well, now you have to know a little something about a chicken and a pig. How many legs does a chicken have? Okay, a chicken has 2 legs. So 2 legs for every chicken. So 2x, 2 times 1 chicken, well, there are only 2 legs. 2 times 2 chickens, now they have 4 legs. Not each, but total. And a pig has 4 legs. So 4y. 1 pig, if we had 1 for y, 4 times 1, 4 legs. If we had 2 pigs, 4 times 2, 8 legs total. Got our 2 equations. Now, we say we have to rearrange 1 to make it equal to y, so we can substitute. So, this one already has y by itself, so if we take it, x plus y is equal to 13. Same process as the last one. All I have to do is minus x, cancels out, and then I've got y equals 13 minus x, and I already have a y equals. So now, I can take that equation and substitute it in for y in our other equation that we didn't rearrange. So, I'll start writing out my legs equation. 2x plus 4 times y. So y is now not y, but 13 minus x. And then finish it out, equals 40. Okay, same process. So that would be 52 minus 4x. Bring down the rest. Remember, it was a positive. All right, combine like terms. 2x minus 4x is negative 2x. Bring down the rest. Okay, minus 52. I'm going to run out of room. So negative 12 equals negative 2x. And then I'm going to say it out loud, but not write it down because I don't have enough room. But if I divide both sides by negative 2, I should have x is 6, positive 6. All right, so that means I know I got 6 chickens. 6 is x, and x was chicken, so I have 6 chickens. So my last step, I got to figure out how many pigs. And pigs was y. So, plugging my 6 back into this equation, y equals 13. And now, instead of minus x, I can minus 6 because I know x was 6. And y is 7. So, again, your answer in context of what you're talking about, which is what you do with the word problem. I know that I have 6 chickens and 7 pigs. All right, so I have more problems that I could show you to practice, but since this is a video, you can rewind and rewatch how I solved them. So I'm going to give you 3 word problems that are very, very similar to these, and I expect you to solve them and bring them in tomorrow. If they're not correct, that's okay because this is a new thing, but I've taught you how to solve them, even if it was brief.